Hello, everybody. This is Mr. Fasoni. Today, we're going to talk about sequences and series a little bit more. And we're going to be talking specifically. We're going to be talking specifically about analyzing arithmetic sequences and series. So we've talked about arithmetic sequences and series in class. Just remember that arithmetic means there's constant addition occurring. So our goals from that lesson were to identify arithmetic sequences, write the rules for arithmetic sequences, and then find the sums of finite arithmetic series. So remember, a series is just a sum of a sequence. And a sequence is just an ordered list of terms that share a rule. And I guess I shouldn't really say terms, I should really say values. They all share the same rule. Pardon the handwriting, I'm apparently in my extra bad handwriting mode. All right, so the first concept we did in class was identifying an arithmetic sequence. So remember, all we had to do to find an arithmetic sequence, if it was arithmetic, was to find if the difference was constant. So that's really fast if we look at these four sequences here. We can just look and see what the differences are, and if they're the same difference every time, then we have a constant difference. So for instance, from 1 to -1 is -2. From -1 to -3 is -2. From -3 to -5, -2. -5 to -7, -2. These are all the same, which means it's a constant difference, which means this is an arithmetic sequence. So we just do this for every one. This is going to be +3. From 8 to 13 is +5. As soon as we've got two different differences, that's kind of strange to say, but they're not the same. And as soon as they're not the same, it can't be an arithmetic sequence. This one, it's pretty obvious. I'm subtracting 18, subtracting 9. Technically, I'm dividing by 2 each time. This would actually be a geometric sequence, but it's not the same again. If we're thinking arithmetically, so again, it's not an arithmetic sequence. And then this last one is kind of hard to see. 1/2 to 3/4 is really adding 1/4. From 3/4 to 1, I'm adding 1/4. From 1 to 5/4, I'm adding 1/4. And from 5/4 to 3/2, I'm adding 1/4. So yes, this is the same as we go from each position to the next. So again, it is an arithmetic sequence. So it goes really, really fast. All you're doing is checking to see if they're all the same. As soon as you've got one that is different from the others, or two different ones, I should just say, at that point, you know it's not arithmetic, and you don't even have to continue at that point. All right, so next up, we talked about the standard equation or the standard rule for finding an arithmetic sequence. And that was, an, which is the value at position n, is equal to a1, which is the value at position 1, plus n-1, which represents the number of differences that you have to take, or number of steps you have to take, you can kind of think about it, or the changes in position that you have to take to go from a1 to an. If n was 10, for instance, to go from 1 to 10, well, it's going to take 10 minus 1 steps or hops or jumps or differences. It's going to take 9 moves effectively. Try to think of, a sequence as positions, right? So to go from position 1 to position 2, that's one difference or one move. From 2 to 3 is another one, from 3 to 4, and so on and so forth, all the way to n. And it's always going to be one difference less than the number n, because I'm already at 1. So to go from 1 to 2 is one move. From 2 to 3 is a second move. So to go from 1 to 3, it's going to be 2 moves or 2 jumps or 2 hops. And then we multiply that by that D value. That D value is our difference. The 2 most important items when we're looking at these are the A1 value and the D value. If we have both of those, then we can build our rules very, very quickly. So the next 3 types of problems are doing just that. We're writing a rule for the nth term of each sequence, and then we're finding A15, the 15th term in the sequence. So we're given some sequences, and this is very nice because if we're given an arithmetic sequence, if we're told it's arithmetic, then we know we're going to have the same difference each time. Each jump I take or each move I take is going to be the same. And if I look at this, to go from 12 to 20, I'm just adding 8. So my first difference is 8. And then if I'm looking at my positions, if I'm looking for A1, the value in the first position, well, I just go to the first position in the sequence, and that value is going to be 12. I now have enough to build my formula. My formula for any position, AN, is going to be equal to A1, which is 12, plus the number of positions minus 1, which represents the number of jumps or hops or steps or whatever you want to call it that's going to take to go from position 1 all the way to position N. And then we're going to multiply that by my D value, which is 8. So now I've got my rule. And if I want to find A15, it's really straightforward as well. A15 is just going to be the same equation, 12 plus, but instead of N, I'm going to write 15 because I know where I'm going to. 15 minus 1 times 8. Well, 15 minus 1 is 14, so that's going to be 14 times 8. 14 times 8 is going to be 80 plus 32, 112. 112 plus 12 is going to be 124. So the 15th position for number 13, this first problem here, is 124. So we can do the same thing for number 15. We find our A1 value. It's right there in plain sight. We find our difference value. Well, it looks like every time here I am subtracting 3, so my difference is -3. And now I build my rule. The value at position N is equal to starting value 51 plus D minus 1, not D minus 1, N minus 1, there we go, times my D value, which is -3. I'm going to put that in parentheses because I've got that negative sign there. I don't want to confuse anybody. So I'm multiplying by -3. So now if I want to figure out A15, again, it's really quick. A15 is going to just be 51 plus 15 is my N value, 15 minus 1 times -3. Oh, I kind of turned off my color coding midway through there. So it's going to be 51 plus 15 minus 1 is 14 times -3. 14 times -3 is going to be -30, -12, -42. So I've got 51 plus -42. Well, 51 plus -42 is just 51 minus 42, and that's going to equal 9. So at A15, my value is 9. And again, we're done. So those ones go really fast. These are kind of like the easy problems because we're given A1 and we're given D. We don't have to solve for anything. So on the next set of problems, we turn up the difficulty a little bit because now we have the D value and a random term. We don't have the first term. We did that in class. So let's just do a couple of these to, make sure we know how to do it. So in this situation, I've got my D value given to me. So I've got half of what I need. But the thing I'm missing still is I don't know what my A1 value is on both of these. So we'll do number 23 first. What we can do, because what's been given to us, we have this A11 value. A11 is equal to 43. So I'm just going to use the equation framework. AN equals A1 plus n minus 1 times d. And from there, all I'm going to do is I'm going to plug in A11. It's going to go right here. We know the value of A11. So instead of writing A11 here, I'm just going to write 43. The 43 is going to be equal to A1, which I don't know, plus, and my n minus 1, well, my n minus 1 is going to be based off of that position number. It's going to be 11. And then that's going to be multiplied by my d value. And I know my d value, that's 5. So now if I look at this equation, I've got everything accounted for. There's a number associated with everything except for this A1. But since I've got every other value, I can just do the order of operations on the right side of the equation until I've worked as much as I can, and then use an inverse operation to get A1 by itself. So I'll do some order of operations on the right side here. I'm going to multiply 5. Actually, no, I'm not going to do that. Why would I do that when I can just subtract 1 from 11? So I'm going to have 43 equals A1 plus 11 minus 1 is 10 times 5. Now I'm going to multiply. I get 43 equals A1 plus 10 times 5 is 50. And now I'm ready to do my inverse operation. I want to get A1 by itself. So I'm going to subtract 50 on both sides. 43 minus 50 is -7, and -7 is going to be my A1 value. Now I have my A1 value. I can build the equation. And I should have given myself a little bit more room. I'll just zoom in a little bit. Now I can fit it a little bit better. AN is going to be equal to A1, which is -7, plus n minus 1 times my difference value, which is 5. So now I've got my rule, and I can use that rule to figure out any position I want. Do we have to come up with? Oh, in the lecture we didn't come up with another term. We looked at the graph of the first 6 terms, and we found that the graph will look like, well, it'll be a discrete graph, but then if we connected the points, we'd find that it would make some kind of line. So it's a discrete graph of what would be a linear function if it were a continuous graph. All right, so that was number 23. Let's do 25 really quickly here. Again, we've got the d value, and we've got a random position. We've got A20 is equal to -27. So I'm just going to fill in what I know. A20 is -27, so that's going to be my AN. It's going to be equal to A1. Don't know what A1 is. Plus n minus 1. Well, my n value, again, is 20 this time. And then I'm going to be multiplying it by the difference value, which is -2. So again, now I just do some order of operations on the right side until I get it to the point where I'm ready to do an inverse operation. 20 minus 1 is 19. So I've got 19 times -2. -27 equals A1 plus 19 times -2 is -38. So I've got plus -38. Well, that's going to be -27 equals A1 minus 38. And then finally, I do my inverse operation. Add 38 on both sides. These cancel on the right. On the left, I get -27 plus 38 is 11. So my A1 value is 11. And now I can build my equation since I know my A1 value. Got that accounted for now. It's not -11, +11. So it's going to be AN is equal to 11 plus n minus 1 times -2. And there's our standard form again. Or our standard rule, I should say, for an arithmetic sequence. All right, so that's like kind of the middle difficulty type problem. The last one we have to do is when we're given two random terms. For instance, on the example that we did in class, we were given two random terms, A5 and A12, but we have no idea what A1 or the difference is. So in these situations, we actually have to set up a system of equations. So I will use, since I'm in the black background, I'll use light blue and yellow. So what I'm going to do is I'm going to create two equations with what I have. So remember, the standard framework for this equation looks like this. And we're going to fill in what we know. So I'm going to do this twice, once for each equation. So the first equation is going to be the blue one. I know that A5 is 41. So 41 is going to be equal to A1 plus n minus 1. My n value is 5. And I'm going to be multiplying by d. I don't know A1 or d. And then I'll do the yellow function, or yellow rule. That's going to be 96 for A10 is equal to A1 plus my position value is 10 minus 1 times d. All right, that's kind of messy. Let's go ahead and simplify. So it's still going to be equal to, well, I'll say these are equivalent since I'm doing kind of both sides of the equation again. 41 is equal to A1 plus 5 minus 1 is just 4, and then 4 times d is d. So all I did was really do some quick order of operations stuff on this end part of the equation. 5 minus 1 gave me 4, 4 times d is just 4d. So same idea on the yellow equation, just to clean it up a little bit, I've got 96 equals A1, 10 minus 1 is 9, and then 9 times d will be 9d. All right, so I've got two equations and two variables that I don't know. I don't know A1 and I don't know d, but what I can do now is I can set this up like a system of equations and I can subtract one line from the other, one equation from the other. So I'm just going to subtract, they're stacked this way, so I'm just going to subtract the bottom from the top. So I'm subtracting 96 from 41. I'm setting this up like like just an addition problem, or that's technically a subtraction problem, I guess. So I'm going to do 41 minus 96. It's going to give me a negative 55. A1 minus A1, this negative sign distributes. Let me distribute that negative sign and get rid of the parentheses. So basically, I've got a negative A1 and a plus negative 9d. Well, if it's a plus negative, I can get rid of that. It's just really minus 9d. So positive A1 minus A1, those cancel, which is good. And then 4d minus 9d is going to give me negative 5d. Well, I can solve for d now very easily. Just divide both sides of the equation by negative 5. Negative 5s go away over here. Got d. And then negative 55 divided by negative 5 is going to give me positive 11. So now I found my d value. That's great. I've got one of the two values figured out. I'm going to go ahead and just put it up here. And now I just have to figure out A1. Well, since I've got one of these two values figured out, I'm just going to plug it back into one of my two equations. So remember, this light blue equation was 41 equals A1 plus 4 times D. Well, if I know that D is 11, I'm going to replace D with 11. I don't know why I wrote 5 over here. This should be 11. I think maybe the 5 that I was dividing by confused me there for whatever reason. D is 11. So now I can just work through this problem. 41 equals A1 plus 4 times 11 is 44. Now I can solve for A1. Subtract 44 from both sides. Those go away. 41 minus 44 is negative 3. So negative 3 equals A1. And now all I have to do is plug that in. Negative 3. So -3 is my A1 value, 11 is my D value, and now I have my rule. I can't remember, did we have to find another position? No, we just had to find the rule for the nth term. And with this rule, I can find any term I want. If I wanted A100, I would just plug in 100 for n. It'd be 99 times 11, which is going to give me like 1,089 or something like that. And then I'm going to subtract 3 from it, so like 1,086. All right, let's do this other one. We'll kind of speed it up a little bit. So again, we're going to create two equations. I'm just color coding them. The colors I pick have nothing to do with anything other than just kind of showing the two separate equations. And I'll kind of section this off. All right, so again, I'm going to just set up my equations. I know that A7 is 58, so it's going to be 58 equals A1, which we don't know, plus n minus 1. Oh, but I do know my n value. My n value in this case is 7, so it's going to be 7 minus 1 times my d value, which again, I don't know. And then my yellow equation is going to be 94 equals A1 plus 11 minus 1 times my d value, which I also don't know. And then I'm just going to clean things up a little bit to create my system of equations. So I've got 58 equals A1, 7 minus 1 becomes 6. And 6 times d is just going to be 6d. Yellow equation, same thing is going to happen. We're going to have 94 equals A1 plus 11 minus 1 is 10d. Now I'm ready to do my system of equations. I'm going to subtract on both sides. So everything's, I'm going to subtract the bottom equation from the top equation. So both sides of the bottom equation, I can't talk apparently, bottom equation have a negative sign attached to them, and then I just treat it like a subtraction problem or addition of negatives. So 58 minus 94, that's going to give me, 36? Negative 36, is that correct? 94 minus 50 would be 44, 44 minus 8 would be 36, yeah. Okay, so negative 36, A1, negative A1 cancel, 6 minus 10 is going to give me negative 4d. And then this is real quick, wrong color. Divide by negative 4 on both sides. Hopefully you see this, and it's very quick. You get 9 equals d. So that's my first value. I need now to get my second value. Well, I'm just going to use my top equation. 58 equals A1 plus 6 times 9. Because 9 is my d value. And then from there, it's just going to be 58 equals A1 plus 6 times 9 is 54. And now I solve for A1. Subtract 54 from both sides of the equation. And I get 4 equals A1. Now I've got my two values that are required to write my standard rule or my general rule or whatever you want to call it, the rule to figure out any position. AN is going to equal to my first position, which is 4, plus the number of steps to go from 1 to n times my d value, which is 9. Now I'm done. So this is like the third type of problem. This requires the most work because we have two unknowns, but those two unknowns are pretty easy to find. We just set up a system of equations to eliminate one of the unknowns and solve for the other. Once we have that other unknown, we plug it back in to one of the original two equations and find A1. All right. And then last but not least in this section, we talked about the sum of a finite arithmetic series, and we had this format to solve for any number of terms in an arithmetic series, a finite arithmetic series. And we talked about how this related to that story of Gauss as a child adding the numbers 1 through 100, and we kind of related that whole story to this generalized equation. So we found very quickly the sum of 1 through 20 for 6k minus 2, but I just want to do a couple more just to make sure that we're on track. So our equation, remember, the sum of n terms, I'm just rewriting it from over here on the left, is n times a1 plus an, that's my average, divided by 2. That's my average for any value in the series. And then so the average value in the series times the number of values gives me the total value of the sum of the series. So we're going to use that. Maybe I wrote that too big with the zoom. We're going to use that equation, though, to solve these series very quickly. So remember, there are just 3 parts of each series. The bottom defines the variable name. In this case, we're using I. The number on the bottom tells us what position we're starting with, which is 1 in this case. The top value is where we're going. We're going to the 20th value. And then the thing on the right is the most important thing. This is the rule that we're using to determine each value. So if I were to step through this, if I was going to go 1 through 20 positions, to find the value of each position, I would have to plug in the position number for I, so 2 times 1 minus 3. And then I'd have to do 2 times 2 minus 3, 2 times, let's zoom in a little bit more. 2 times 2 minus 3, 2 times 3 minus 3, and then 2 times 4 minus 3, all the way up to 2 times 20 minus 3. And then I'd have to add all these values together to find the sum. I could do that manually, but that would be 20 little equations that I have to plug in a value for, where I'm multiplying by 2 and subtracting 3 on each one. And then once I find those 20 values, then I'd have to add them all up, which results in a lot of possibilities to make an error. But remember, our standard way to find this sum quickly is that all we need really are A1, the value of the first position, and AN, the value of the last position. So I can solve those pretty quickly. A1 is just going to be 2 times 1, which is 2, minus 3. So A1 is going to be -1. In fact, I'll write A1 equals -1. And then A20, that's just going to be 2 times 20 is 40. 40 minus 3 is 37. So A20 is going to equal to 37. With those two numbers, I can then plug in everything I need. The sum of the first 20 positions is going to be equal to the number of positions times, A1, which is -1, plus A20, which is 37, divided by 2. And this part in the blue is the average value of any position in the series. So if I have the average value of all the positions in the series and I multiply that average value by the number of positions, I'm going to have the total sum. So now it's just order of operations stuff. It goes very quickly. It's going to be S20 is equal to 20 times -1 plus 37 is 36 over 2, which is equal to 20 times 18. 36 divided by 2 is 18, which is equal to 360. So S20 is equal to 360. Or in other words, the first 20 terms of this series, terms 1 through 20, add up to 360. All right. So let's step through this again. We'll kind of speed it up a little bit. Again, we're going from 1 to 33 now, and our rule is 6 minus 2i. So all I need to do is I need to determine the value of A1. Well, that's going to equal just 6 minus 2 times my value, which is 1. So it's going to be 6 minus 2, which is going to equal 4. So A1 is equal to 4. A33, I plug in 33, it's going to be 6 minus 2 times 33. That's going to be equal to 6 minus 66, which is equal to -60. So the 33rd value in this series is going to be -60. And now to solve for the sum of all those values, 1 through 33, it's going to be the sum of the first 33 values is equal to the number of values, that's 33, times the average value, which is going to be A1 plus A33 divided by 2. I can very quickly solve this. That's going to be 33 times. A1 is 4, A33 is negative 60, so that's going to be negative 56 divided by 2. And then from there, I just keep on going. 33 times negative 28. And now they're going to make me work a little bit. 33 times negative 20, that's going to be negative 660. That's then 33 times 8 or negative 8, it's going to be, I don't know, 240 plus 24, negative 264. And I add those together. That's going to give me negative 924. I should probably check that. I like to do mental math, but let's just make sure. I'm multiplying a negative times a positive, so it's going to be 33 times 28, negative, all right, negative 924. So the sum of the first 33 terms in the series is negative 924. And we're done. All right, so that's it. These are the types of problems from 8.2 that you're going to be doing. If you have any questions, of course, feel free to ask me, message me on Teams, send me an email or whatever. I hope this is helpful. If you need anything, let me know. Otherwise, I will see you in class. Thanks.